In some relational databases, like SQL Server or MySQL, we have the concept of transaction, which basically means a group of operations that should be performed as a unit. So either all these operations will complete and change the state of the database, or if something fails in the middle, all these operations that have been applied will be rolled back and our database will go back in the initial state. Now, in MongoDB, we don't have transactions as we have in these relational databases. We have a technique called two-phase commit, which is really beyond the scope of this course. But if you want to learn more about it, let me show you the right page in the documentation. So search for MongoDB two-phase commit. Okay, so here, perform two-phase commits. This document clearly explains how to perform two-phase commits using a real-world example. Now, in this lecture, I'm going to introduce you to a library that gives us the concept of transaction, but internally, it implements this transaction using the two-phase commit technique. So, back in the terminal, let's install Fawn, F-A-W-N. So we can see the version I have installed is version 2.1.5. Now, back in the code, here in rentals.js, on the top, first we need to load Fawn. So, constant Fawn, we set this to require Fawn. Now, this is a class. It has an initialize method that we need to call right here. So, fawn.init, and we pass this mongoose object that we loaded on line 4. So we pass this here, okay? Now, back in our post method. So this is where we create a rental object. Now, we are no longer going to create this rental and update the movie explicitly. Instead, we're going to create a task object, which is like a transaction. So let me delete these 3 lines. Here we new up fawn.task. Now here we can add one or more operations, and all these operations together will be treated as a unit. So we want to save this new rental to the rentals collection. So we call save, pass the name of our collection, which is rentals, and as the second argument, we pass our new rental object. Note that here, we are working directly with the collection. That's why we need to pass the actual name of the collection, which is plural, not singular. And also note that this name is case sensitive. So in MongoDB Compass, you can see the name of our collections, they're all lowercase. Okay? So this is our first operation, saving the new rental. Now, as part of this unit, we also want to update the movies collection. Here we pass a query object to determine the movie or movies that should be updated. So underline ID, we set this to movie.underline_ID. And finally, the third argument is our update object. So here we can use the increment operator. We set the value of this to an object. The target property we want to update is number in stock. Now we want to decrement the value of this property by 1. So we pass -1 here. So these are 2 operations. Now maybe in your application, as part of performing this transaction, maybe you want to remove a document somewhere else. So here we have another operation, .remove. You can read more about Fawn on their GitHub page documentation. So after you chain all these operations, then finally you need to call run. If you don't call run, none of these operations will be performed. All right, now, it's possible that something fails during this transaction. So we need to wrap this in a try-catch block. So here I'm going to add a try block. I'm going to move all this code inside the try block. So this is for our success scenario. Now, if something fails, we should catch an exception here and return a 500 error to the client. So response.status 500, which means internal server error. with a message like something failed. Now, in a real world application, at this point, you want to log this exception so later you can come back and see what went wrong. We're going to have a separate section in the course about error handling and logging. So for now, let's not worry about this. So also, let's add some indentation here. Now this looks cleaner and more readable. So back in MongoDB Compass, I'm going to delete the rentals collection, rentals. Now back in terminal, let's run the application, nodemon. So our application is running, beautiful. Now back in our database, look at our movies collection. So here we have a movie, and number in stock is 8. So I'm going to create a new rental. Then we're going to come back here, and this number should be 7. So let's go back to Postman. So I'm going to send a post request to our rentals endpoint. And here in the body of the request, I have a valid customer ID and movie ID. So let's send this. Okay, here's our response. Beautiful. So this is our new rental object. You can see data out, ID, customer, and movie. Now back in the database, here in the movies collection, I'm going to refresh this list. Look, number in stock is now 7. So this verifies that our transaction completed successfully. Now I've got a question for you. So here we create this rental object. We only set customer and movie. Then in our try block, we create this task, run it, and then send this rental object to the client. So in this code, we didn't set the ID or date out properties. But in the body of the response, you can see both these properties are set. So how did this happen? Nowhere in this code, after we ran this transaction, we reset the rental object. So how did we get the ID and date properties? Perhaps you expect MongoDB to set these values for us, but actually no. In MongoDB, we don't have these default values. We define them in our Mongoose schema. So when we create a new rental object, Mongoose knows the schema for this object. It looks at various properties and sets the default values. The same is true for the ID property. So more accurately, MongoDB doesn't set this. This property is set before we save this document to the database. I didn't tell you this earlier because I didn't want to confuse you with too many details. There is more to ID that we're going to cover in the next lecture. But let me show you one more thing before we finish this lecture. So back in MongoDB Compass, let's click this refresh button. So here's our built-in database, and in the list of collections, you see this new collection. We did not create this anywhere in our code. So where did that come from? This Fawn library that we installed uses that collection to perform two-phase commits. So when we run this task, it adds a new document to that collection, which represents our transaction. Then it will execute each of these operations independently. And finally, when all these operations are complete, it will delete that document from this collection.